Okay, so till or Friday, what we did was first we had started following the steps of identifying the minimum element in the rows and columns and then deducting them from each of the other elements that we did. Then we drew lines, horizontal and vertical lines, so that the lines touches all the zeros, and the condition is you have to draw the minimum possible lines. Okay, once you finish of drawing the lines, then you should think of some other possibilities as well, that if in other way it can be drawn as well, so that the number of minimum, okay Nidhi, no problem, so that the number of minimum number of the vertical and horizontal lines are minimum. All right, so that we followed, and then we found that, then what is our next step? As a next step, we have to see that the number of the horizontal and the vertical lines should be just equal to the order of the matrix. Should be equal to the order of the matrix. So when we counted the number of lines that we had drawn, we found that the number of lines are 4, right? And the order of the matrix is 5. So that doesn't follow the first condition. Had it followed the first condition, then that would have been the end of a sum and we would have gone for the assignment. But that did not happen. So we had to move ahead. Then moving ahead, what we had to do? We had to identify the minimum uncovered element. Okay, minimum uncovered element. What is the meaning of uncovered element? It means the elements through which the horizontal and the vertical lines have not passed. Okay, that is the meaning of uncovered elements. So you have to find out the minimum uncovered element, and then we'll have to deduct that minimum element from all the other uncovered elements. And most importantly, you have to learn this step, that is, you have to add that minimum uncovered element to the elements which are falling at the intersection points of the horizontal and the vertical lines. Okay, so you have to remember this step. Otherwise, you're not going to get the best possible assignment. Otherwise, you're not going to get the best possible assignment. So this till this step we had completed, right? So now we get the second modified matrix by subtracting the smallest uncovered element from the remaining uncovered elements and adding it to the element at the point of intersection of lines. So that is how we got this matrix. We had not done this crossing and circling part. So in your copy, it should be such that a clean matrix is present, where you have added the number 2. We had identified the minimum uncovered element is 2, where you have to add this 2 to the intersecting points, that is 7, 0, 4. These 3 are the intersecting points, right? So you had to add this 2 to these 3 elements and deduct the 2 from the rest of the uncovered elements. Okay, you have to understand that only from the uncovered element this number should be deducted. All right, and point of intersection will be covered one, but you have to add the minimum element to the point of intersecting elements. All right, so that is how we should get we had got a matrix, and it should be clean in your copy as far as our number of steps being covered till Friday. All right. So on that clean matrix, again we will draw a line, draw the number of lines. Okay, so now in today's step, the next step is to draw the lines again. What sort of lines? The lines should cover all the zeros. Okay, you draw the lines now. With a pencil you should draw the lines. Okay, in your fresh copy, in your examination also, matrix you write in pen, but the lines should be drawn with pencil, because there you might have to wipe off and then draw, wipe off and then again redraw. So that is how, why you should draw the lines with pencil. Okay. So draw the lines now and try to cover all the zeros. And the condition is the lines, number of lines should be minimum. Draw the lines. Okay, so have we drawn? Have we drawn the number of lines? Okay, so how many have you got? Those who have drawn, tell me. Three of you tell me randomly. Any three of you tell me how many numbers you have got. Those who have drawn the numbers, among them, yeah, 5. Okay, then. Next, anyone?
5.
5, okay. Another one,
5.
please. 5, okay. So all of you probably have got 5. Randomly I asked 3. So, and also after drawing, you should check whether it is the minimum possible number also. Okay. If there are any other option available, that also you should avail. But I think here you will have to draw 5 lines. Otherwise, it won't be possible to cover all the zeros. Okay. So now when you are getting 5 lines, that means it is just equal to the order of the matrix. That is 5. Order of the matrix means if it is a square matrix, the number of row and the number of column, which is equal. That is the order of the matrix. Okay. So here number of rows are 5, number of columns are also 5. So the order of the matrix is 5, right? So now what we can say, we will, now you write these lines. Number of lines drawn to cover all zeros. You write this line. You can see on your screen also. If my voice breaks, you can see from the screen as well. Number of lines drawn to cover all zeros. Number of lines drawn to cover all zeros equals to capital N equals to 5. Number of lines drawn to cover all zeros equals to N equals to 5. So we had mentioned the number of lines drawn to cover all the zeros by capital N. So now we have got the capital N to be 5. Okay, Nidhi has also replied 5. Okay, Nidhi. So the number of lines drawn to cover all zeros is 5. Then next line you write the order of the matrix. You write the order of the matrix small n equals to 5. The order of the matrix small n equals to 5. The order of the matrix small n equals to 5. Okay. Now, what would you have done had you not got the number of lines equals to order of the matrix? you would have followed the previous step once again. That means identifying the minimum element from the uncovered elements and then deducting them from all the other uncovered elements and adding the number to the intersecting points. Okay, again you would have followed that step. Since we have got the number of lines equals to the order of the matrix, so that is the end of all the steps. Okay, now we can determine the optimum assignment. Then next line you write, hence capital N equals to small n. Then you write, hence capital N equals to small n. Hence capital N equals to small n. Full stop. Then you write, now we determine the optimum assignment. Now we determine the optimum assignment. Now we determine the optimum assignment. Okay. So now listen to me carefully, very carefully. This is the final step. How to assign. Okay. How to assign. So in this regards, I would take you to the steps. See. Yes. Now see, step 7 is the assignment step. All right. How to assignment? Examine the rows successively until a row-wise exactly single zero is found. This line is very vital. Okay. What you have to do is, step 7 is the step of assignment. Okay. What you have to do is, you have to examine the rows successively. That means one by one, minutely you have to examine the rows until a row wise exactly single zero is found. What does this mean? You have to go on examining the rows until and unless you get a row which has an exactly single zero. Okay. Then what you will do? You will circle this zero to make the assignment. That is our first assignment. Okay. We will circle that zero in order to make the assignment. Then mark a cross over all zeros if lying in the column of the circled zero, showing that they cannot be considered for future assignment. So once you find a row with having a single zero, you will circle that zero and then you will move to the particular row or particular column in which that zero is falling. Okay. Row wise, you will identify a row which is having a single zero. So you will circle that zero and then you will check the column in which that zero is falling. Okay. And if any other zero is there in that column, you will mark a cross if lying in the column on the circle zero, showing that they cannot be considered for future assignment. Continue in this manner until all the zeros have been examined. Repeat the same procedure for columns also. Then repeat step 6 successively until one of the following situation arises. But if no unmarked zero is left, then the process ends. Or if there lie more than one unmarked zero in any column or row, circle one of the unmarked zeros arbitrarily and mark a cross in the cells of remaining zeros in its row or column. This is a rare case, okay? This may not happen, but if happens, suppose after marking all the zeros with circle and a cross, still you find that there is lying more than one unmarked zero in any of the row or column. So then what will you do? Then you will circle one of the zeros which has not been marked arbitrarily. Just randomly you will circle the zero and mark a cross in the cells of the remaining zeros. Whatever in those rows and columns the zeros will be left, you will mark a cross. Then you will repeat this process until no unmarked zero is left in the matrix. Okay. So actually the point is there should be no zeros left out in any of the matrix. Okay. We will come across, if we come across this situation, we will understand it better. But in most of the cases, you will find that all the zeros have been marked. That is a rare case. So hopefully you have written this particular. Okay. After that line, hence n equals to n. Now we determine the optimum assignment. After that line, you draw the matrix again. A fresh matrix you draw. Fresh matrix having the numbers same as the previous one where you had drawn the lines. A fresh matrix you draw now in your copy. Okay. Draw a fresh matrix in your copy, keeping the numbers same. Keeping the numbers same, draw a fresh matrix in your copy. The numbers will be 9, 0, 0, 2, 6, then 6, 2, 3, 0, 3, then 4, 0, 1, 0, 0, then 0, 0, 3, 0, 0, and last row will be 2, 1, 0, 0, 2. Okay? So now see, now find out a row which is having an exactly 1, 0 in it. There can be more than 2 rows also, then you will select any one. Alright, so in this problem, first row contains more than 1 0. Right, first row is having 2 zeros. So proceed to the second row. Is it the row which is having exactly 1 0? Is it the row? Is second row is the row which is having exactly 1 0? Tell me. Unmute and tell me.
Yes, ma'am.
Yes. In the second row, exactly 1 0 is there. Moving ahead to the third one, see there are 3 zeros. Fourth one, there are 4 zeros. And fifth one, there are 2 zeros again. So, second row is the one which is having exactly 1 0. So, quickly circle that 0. You can put a box also, no problem. You can circle or you can put a box also. In the exactly 1 0 present in the second row, put a circle or a box. Okay. Then the corresponding cell is what? The cell name is what? B4, right? B job machine 4, isn't it? B4. Circle this 0, thus making an assignment. When you're circling this, that means you are assigning the job B4 to B. You're assigning the job was in the row side or column side. Just a minute. I'll just see the. Yes, job was at the top, right? So when you are marking the 0 present in the cell number B4, that means you are assigning the fourth job to the machine B. Okay. So circle this 0, thus making an assignment, right? Now, our next step is what? At the same time, simultaneously you will have to do, otherwise you will miss the step, okay? Once you circle that 0, then quickly look at the column in which this 0 is falling. So it is falling in the fourth column. So what you have to do is, other than that 0 which you have circled or put a box, put a cross on all over the other zeros present in that particular column. That is column number 4. Leaving that one which you have circled, there are 3 more zeros in that column. So put a cross on all those 3 zeros. Okay. Now mark cross for all other zeros in its column. If any doubt, you can stop and ask me. Okay. So what does it indicate? It indicates that this job, which is job number 4, cannot be assigned to any other machine. It has already been assigned to machine number B. Okay. So it cannot be assigned to any other machine. That is why you are crossing the other zeros, right? After crossing, those crossed zeros will not be considered anymore. Okay. Then, after you are having a fresh copy in front of you, so tell me which is the next row which is having exactly 1 0. Which is the next row which is having exactly 1 0. Those crossed zeros will not be considered anymore. Okay. Then which is the row which is having exactly 1 0? Tell me. which is the row that is having exactly 1 0? Row E. Okay. Okay, fine. This pop messages are not, making sounds when they're popping. Okay, anyways, so the next row is the fifth row, which is having exactly 1 0. And what is the cell number? It is called E3, right? The cell is called E3. Quickly circle that cell, that 0. Quickly circle that 0 in cell E3. When you are circling, what does it indicate? You are assigning the job 3 to machine E. Right. The job 3 has been assigned to machine E. Then quickly go through that row column in which this 0 is falling. It is falling in the third column. Is there any other 0 other than that? Yes, there is one, right, in the first row. So cross that 0. That means this job number 3 cannot be assigned to any other machine. Okay. Then tell me, after crossing this, then it will not be considered anymore. Then tell me which is the row which is having a single 0.
A.
A. A is next. A is having the perfect single 0, right? So quickly circle that. Circle that, which means job 2 has been assigned to machine A. Okay. So once you circle that, then put a cross on rest of the zeros present in that second column. Put a cross in rest of the zeros present in the second column. Okay. After putting cross, they will no longer be considered. Then tell me which is the row that is having perfect 0. Next row, please. That is having the perfect 0.
C.
Okay. It is C, right? C is having a perfect 0. Quickly circle that. That means job number 5 will be assigned to machine C. Job number 5 will be assigned to machine C. Okay. And in that column, this 0 is falling in the fifth column. There is one more 0 in this column. Cross that. Cross that 0. That means job number 5 cannot be assigned to any other machines other than machine C. How many assignments have we made? I'm just jumbled up. I'm not doing it in a fresh copy. You are doing. So tell me, how many assignments have we made till now? How many assignments? That means how many circles? 0, 4 or 5 done?
4.
4. Okay. Then last one will be which one? Last row will be which one? That is having a perfect single 0.
D.
D. Okay. Very good. So D is our last row which is having a perfect single 0. So quickly circle that. It indicates that job 1 will be assigned to machine D. Job 1 will be assigned to machine D. Okay. I hope all of you are understanding. Okay. So now we have 5 circle 0. That means all the jobs has been assigned to all the machines. This is very interesting. When you follow this step, you will never find a circle 0 in any you'll never find more than one circle 0 in any column. That is a very interesting process. This is like a game, right? This is like a game. You take QTM as a game for you. This is game, right? When you start putting circle on all the zeros following this step, after finishing off, you will find that all the jobs has been assigned to all the machines. No machine is left out. Okay. So what is our final assignment? Next step you write. Next step you have to make this column. or you can do it in your own also, no problem. It's not that this is the hard and fast rule of following. So optimal assignment and optimum cost of assignment are as follows. You write like this. Optimal assignment and optimum cost of assignment are as follows. This paragraph you don't have to write, okay? Don't write this paragraph. This is written because this is the first sum, and in this book, the first sum is explained elaborately. So don't write all the steps. This has been done for your understanding. From the next sum itself, you will not see this paragraph. So after drawing the circle then process, you will write this line. Optimal assignment and optimum cost of assignment are as follows. Optimum assignment and optimum cost of assignment are as follows. Okay. Then you make 3 columns: job, mechanic, cost. This will depend on the information given in your question. Okay. If activity is mentioned, you write activity. If person is mentioned, you will write person. Here, job and mechanic was mentioned. So you will write job, mechanic, and cost. Okay. Now, next you will write job numbers 1, 2, 3, 4, 5. In the job column, you will write 1, 2, 3, 4, 5. So 5 job. Then you will have to look at the circle 0. That job 1 has been assigned to which mechanic? Job 1 has been assigned to mechanic D. See the previous table where you have drawn the circle and the crosses, fill up this column. Job 1 assigned to mechanic D. Job 2 assigned to mechanic A. Job 3 assigned to mechanic E. Job 4 assigned to mechanic B. And job 5 assigned to mechanic C. Like that you will write. Alright. Then you will take the cost from the matrix. From where will you take the cost? You will take the cost from the given matrix, that is from the problem matrix. Okay. You will not see the modified matrix, but you will see the problems matrix, which was preliminarily given to you. From there, you will write the cost. The cost, match it, and then add them. Add all the costs. Okay, do it. Done? Is it done? Is there any doubt in this? You just put the cost and add them all. Okay.
Ma'am, how do we find the cost?
Cost from the questions matrix. The question was given to you, no? So just in that particular assignment, you have to see the from the question and then you have to draw. Okay.
Yes, sir.
Any doubts, you ask me after the classes, all right? It's 7:35. You can leave. I've taken the attendance. 18 only today. 17 rather. Yeah, 17. Okay, so then see you at 9:20 again. I'm leaving then. You have any doubt, you can ask tomorrow or you can ask after the classes also. Okay, bye-bye. See you at 9:20.